Bhagalingaya Namaha. Good morning. Yesterday preparation of alkyl cyanides and isocyanides we are discussing. Different methods are there for alkyl cyanides as well as alkyl isocyanides. Alkyl isocyanide, the main reaction will be carbylamine test. Carbylamine test, from which alkyl isocyanides are going to prepare. That is a offense order compound. That is the reason why primary amines are going to distinguish from secondary and tertiary amines. Clear na? And one more will be RKSO4 if you take. RKSO4. What here gets substituted? From potassium sulfate, one of the potassium gets substituted by alkyl. That's it. If this R is K, that is a K2SO4, potassium sulfate. From potassium sulfate, one of the potassium gets substituted by alkyl group when it is treated with potassium cyanide. You come to know easily na? This cyanide transferred to alkyl, therefore alkyl cyanide along with that K2SO4. Just by looking, even if they change something, you can able to manage that. So alkyl cyanide along with that potassium sulfate is going to form when potassium cyanide treated with alkyl potassium sulfate. Clear? Like this, methods of preparation are be done. Then properties, if you go, physical properties. Physical properties, alkyl cyanides are there, say, lower membered alkyl cyanides are soluble in water. Lower membered alkyl cyanide, suppose methyl cyanide is there, is able to soluble in water. Ethyl cyanide also somewhat, but compare with methyl cyanide, ethyl cyanide solubility in water is less. As alkyl chain increases, the solubility of alkyl cyanide in water decreases. Clear na? Because this alkyl is aprotic end, whereas cyanide is a protic end. It is aprotic end. Aprotic end is covalent in nature. That covalent in nature, insoluble in water. So as the alkyl chain increases or bulkness of the alkyl group increases, the solubility of them in water will be decreases. Clear? Now, boiling points and melting points if you go, as you go on increase, this alkyl chain if increases, naturally boiling points and the melting points are going to increase, because this bigger area is surrounded by intermolecular interactions or more. As the size increases, the space provided by a molecule to interact with a side molecule is going to increase. As the interaction increases, to detach that, definitely temperature required will be more. So as the molecular mass of alkyl cyanides increases, generally boiling and melting points are going to increase. That generally word I am using, say, is applied for melting point. Melting point, even number of carbon atoms containing cyanides, melting points will be higher than odd number of carbon atoms containing alkyl cyanide. In general, you remember, right? Even number of carbon atoms, if there, symmetricity is more. If the compound is symmetric, then melting point will be more. Unsymmetric, melting point will be less. Nothing but C4 melting point may be higher than C5, even though C5 is bigger in size compared with C4. So even number of atoms, that is symmetricity containing alkyl cyanides, melting points will be higher, but boiling point not applied. Boiling point, as the number of carbon atoms increases, boiling point increases. Clear na? So that is solubility. Here, suppose this is increasing, protic solvents decreases solubility, aprotic solvents increases. Covalent solvents may, as the number of carbon atoms increases, alkyl cyanides ka, their solubility go on increases. Clear? So that is solubility. Physical state up to C2. Gases more than that, C3 to C11 in general are liquids, more than C11 are solids. Clear? Then isocyanides if you consider, isocyanides boiling points varies. Cyanide and isocyanide, if both of them are isomeric in nature, C2H3N. C2H3N is CH3Cn. CH3NC. Same molecular formula. Isomeric cyanides and isocyanates, if you consider, isocyanide boiling points are lower than cyanides. Isocyanide boiling points lower than cyanides. Nothing but isocyanates are reactive than cyanides. Their chemical reactions, let us see. Chemical reactions, if you come with hydrolysis with water in basic medium or acidic medium, similar type of products. Here this medium, what it will do, the medium water rate of ionization increases, that is H plus and OH minus readily able to form either in presence of basic medium or in presence of acidic medium. So that RCN with water, either of the mediums, in this way water ionized into H plus and OH minus, pi electron polarized towards nitrogen side because that is more electronegative. This OH minus go and add on carbon atom, H plus go on add on nitrogen atom. Therefore, RCOH double bond NH. Correct? Huh? What is this? This is ene. It is ol. So, enol. Enola. And here not carbon, more electronegative nitrogen. Thus, definitely toward the nitrogen side the pi electrons are going to polarize. When like this pi electron polarize, it will become minus, it will become plus. Correct? Huh? Immediately, whoever the hydrogen attached to oxygen sacrifice the sigma pair of electrons. Whenever like this, it sacrifice the sigma pair of electron, O will become a negative sign, H will become a positive sign. Internally, this proton migration takes place towards nitrogen. Correct? Whenever proton shift is there, that shift of proton backward reaction, there exists reversibility. Equilibrium exact I cannot say. So that it get converted into this minus and plus between them, one more bond. Here one bond is going to break down and H plus goes to this end. Therefore, you will get RCONH2. Is alkanamide? Alkanamide. Initial step, when this cyanides undergo hydrolysis with water, with 1 mole of water, alkanamide through ketoenol tautomerization. Tautomerization, shift of proton. This is ketone. Now, this will be on 1 more mole of water. 1 more mole of water. Here bond is going to cleave. It will become minus, it will become plus. That plus accept OH minus from water, along with that ammonia liberates. Clear? Na? Here, one time on the same, this question came in entrance. The number of moles of water required. The number of moles of water required for hydrolysis of cyanide. How many moles are required here? 2 moles. Generally, here RC triple bond N with hydrolysis. If 3 bonds are going to break down, it will become del plus 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 del minus minus minus. So, 3 moles of water if you take, 3 hydroxyl group goes to carbon, 3 H plus goes to nitrogen. Therefore, RCOH, carbon bearing more than 1 hydroxyl group, unstable, with the liberation of ammonia only, na? NH3. It is unstable, again here lose water molecule to give RCOOH. ऐसा बोलते, here 3 moles consume होता, again 1 mole given back. 3 moles consumed, 1 mole given back, net consumption 2 moles of water. Clear, na? So, alkyl cyanides upon hydrolysis with water to give alkanamide followed by alkanoic acid with the liberation of ammonia. It is alkanamide, an intermediate step. This further hydrolyzed with 1 more mole of water to give alkanoic acid with ammonia. Clear? Suppose this alkyl group is methyl, then ethane nitrile will give CH3COOH. CH3COOH with ammonia. Here methyl cyanide, if cyanide we consider as a nucleophile, inorganic nucleophile is an ion, at that time here 1 carbon alkane nitrile going to give 2 carbons alkanoic acid. Here C is there, see that C as a extended chain we could not consider if it is inorganic nucleophile. At that time this carbon will increase the chain, thus sometimes we can say it as chain ascending reaction. This carbon if includes here, at that time same chain, here 2 carbons, there also 2 carbons, clear na? If we consider it as inorganic nucleophile, at that time chain length is increased. So like this, with water in acidic medium or basic medium, alkyl cyanides undergo hydrolysis through ketoenol tautomerization. At that time here kya hota again, here suppose 2 hydrogens are there, see these 2 hydrogens due to more electronegativity of oxygen, like this shift, it will become positive, it will become negative. One of the hydrogen like this sigma pair of electron given to more electronegative nitrogen, and this H plus transferred to here to give back this one. Clear na? So ketoenol, but this rate will be very less, this rate will be more. It is less stable compared with this. Enol is always less stable compared with keto form. Okay na? So that is hydrolysis with water. Suppose with hydrogen sulfide H2S, same like water can be take, that is RCN with H2S, H2S, H plus and SH minus, like this polarization minus plus. So RCSH double bond NH, again like this polarization, here in this way sigma pair of electrons, this is minus, it is plus, it is also plus, internally it is transferred to it, will give us RC double bond SNH2, RC double bond ONH2, RC double bond SNH2. It is thiona, it is alkanamide, it is thioalkanamide. It is alkanamide, whereas it is thioalkanamide. Clear? So in that way with the H2S, single step only, again it further with one more H2S, unstable. 2 sulfurs are there, see bigger one, 2 sulfurs on same carbon, here hindrance will be more, so that next RC double bond S, OH is there, say that is unstable. That is the reason why this only difficult, thioalkanamide, up to that it is able to form, but later hydrolysis like water is difficult. Clear? So that is with H2S. Next, reduction. Reduction RC triple bond N, reducing agent. Reducing agent, suppose metal ethyl alcohol, nascent hydrogen liberates. Metal with ethyl alcohol, nascent hydrogen liberating. That liberated nascent hydrogen, 2 pi bonds able to break down between carbon and nitrogen, but one sigma bond breaking difficult. So that here by breaking 2 pi bonds, here 2 hydrogens will join, this sigma bond as it is, and nitrogen also 2. So here RCN reduction with sodium ethyl alcohol to give a primary amine, it is the primary amine. Already in primary amine preparation we used. Suppose here hydrogen in platinum or lithium aluminum hydride, when we use, this reaction is Mendes reduction. When we use here the reagents, reducing agent, hydrogen platinum or lithium aluminum hydride, the name reaction is Mendes reduction. Sodium ethoxide, a primary amine. Products will be same reactant, same product. Those reducing agents will release the nascent hydrogen and convert into primary amines. This is the reduction. Okay. Next, one more reduction also here there. Stephen's reduction reaction. Here RC triple bond N, reducing agent is hydrochloric acid with stannous chloride. HCl with stannous chloride. Name reaction, the reagents compulsory you must know. So, alkane nitrile upon reduction with HCl in presence of SnCl2. Suppose 2 moles of HCl, here SnCl4, stannous chloride convert into stannic chloride. Stannous chloride convert into stannic chloride with the release of 2 nascent hydrogens. Those 2 nascent hydrogens are going to break one of the pi bond. 2 pi bonds now. So, therefore, RCH double bond NH. Correct? It is imine. Imine. This imine upon hydrolysis with water, HOH. Again, one more mole of the pi bond is going to polarize towards nitrogen side. Thus, here plus minus minus plus RCH OH NH2. Correct? The carbon, this carbon is having 2 nucleophiles. One is hydroxide, other is amine. NH2 and OH. Bearing one carbon, 2 nucleophiles or conjugate bases. Stability is less. That's why I kept that in square bracket. Here, carbon bearing more than one hydroxyl group is unstable, loose water molecule. In the similar way, here instead of OH minus, NH2 minus is added. You know that NH2 minus is still strong conjugate base compared with OH minus. OH minus is a conjugate base of water, whereas NH2 minus is conjugate base of NH3. Right? NH3 is an acid to the NH2 minus. So, NH3 acidic strength is very weak. Actually, that is the base. So, that is the reason why water only strong acid compared with ammonia. Ammonia is an acid. Therefore, ammonia released NH2 minus is very strong. That could not exist as it is. Therefore, here what happens? Here oxygen can withdraw a sigma pair of electron due to more electronegativity of it from OH bond. At that time, this adjacent sigma bond is going to break down. Even though it is a sigma bond, NH2 minus is a strong conjugate base, eagerly required a proton to convert as ammonia. That is the reason why C and N sigma bond is going to break down. If it is breaking down, here minus, here plus, here minus. Therefore, internally this proton goes to NH2 minus. What eliminates? NH3 liberates. Along with that, RC double bond OH. RC double bond OH only, na? It is alkanol. Alkanol. By this method, preparation of ketones not possible. A method से कीटोन प्रिपरेशन पॉसिबल नहीं होता. कीटोन प्रिपरेशन होना बोले तो इधर देखो, फ्रॉम दिस कंपाउंड इज फॉर्म्ड. करेक्ट? ये हाइड्रोजन नहीं रहना कीटोन होना बोले तो, दिस हाइड्रोजन शुड नॉट. करेक्ट? हियर अल्काइल रहे तो कीटोन होता, बट फ्रॉम CN रिडक्शन ऑन दिस कार्बन कैन वी गेट अल्काइल ग्रुप? नो. सो देयरफॉर बाय दिस मेथड हियर कीटोन्स नॉट पॉसिबल. Ketones are not possible by this method, only aldehydes. Here, this method is used to prepare the aldehyde also, na? Alkane nitrile, upon reduction with this, you must remember, stannous chloride with HCl. It is converting into stannic chloride with the release of hydrogen. Those hydrogens will go and add on this triple bonded CN. Therefore, double bonded NH imine is going to form. That imine upon hydrolysis with water liberate the ammonia with the formation of aldehyde. Clear na? RC, OH and NH2 and like this sigma pair of electron shifted to oxygen side, that proton internally shifted to NH3 and CN sigma bond is cleaving and liberate the ammonia. Clear? So it is one more property of alkane nitrile. And with Grignard reagent RMgX, see RC triple bond N with some R dash MgX. You know Grignard reagents importance. Grignard reagents are going to yield what? Alkyl carbene ion. It is plus, it is minus. And pi electrons polarized like this, minus plus. The carbon accept alkyl group. Therefore, RCR dash double bond N MgX. It is an adduct. Grignard reagent will go and added. Complete reagent will go and added on reactant. Obtained product known as an adduct. This adduct upon hydrolysis with water, H plus and OH minus. Again pi electron polarized towards nitrogen side, it will become plus, it will become minus. This carbon accept OH minus from water. Therefore, RCR dash OH bond N, this takes H, correct? Like this polarization from this H plus. So, OH minus accepted by carbon. NH and MgX, correct? R double bond N and water. R double bond N, C double bond N, between carbon nitrogen electronegativity difference is there. Pi electron polarized towards nitrogen side. So it is a minus, it is plus. That plus accept the OH minus from water, and N minus accept the H plus from water. So this is the compound. And here what will be takes place? Again, this group and this group, two groups are bulk existing on same carbon atom unstable. So that again this will be, see, just by writing in this way you come to know what is going to happen. So in this way, oxygen due to more electronegativity. Now CN sigma bond is going to cleave like this, during which it is plus minus plus minus. That minus internally accept the proton. So it is going to yield RCR dash double bond O plus NH2 MgX, correct? NH2 MgX ketone is able to form. See here alkane nitrile with Grignard reagents to give an adduct which upon hydrolysis with water through internal shift of proton is yielding ketones. Preparing by this method aldehydes are not possible again. Suppose aldehyde hona, this must be HCN. ये HCN होना. Grignard reagent बोले तो definitely HMgX तो not possible. Grignard reagent is what? Alkyl magnesium halide, but not H magnesium halide. So here HCN polarizing in this way, C triple bond N is difficult compare with H plus and Cn minus ionization. If it is H is there, HCN here ionization will give and H plus will come outside. Therefore, getting of C triple bond N polarization will be difficult. By this method, preparation of aldehyde is difficult. Ketone comfortably we can prepare. Like this, with Grignard reagents, alkane nitrile will give an adduct. That adduct upon hydrolysis with water to give ketones. Either alkyl group, you take methyl, ethyl, you can take. Okay, na? That is with the Grignard reagents. And next, clear? Here, different Grignard reagents they may give. Instead of this is methyl, ethyl, isopropyl they may give. And next with ammonia. Alkane nitrile with ammonia. Is there reaction? Possibility is there? In what way you have to think? Suppose RC triple bond N with ammonia. Now you come to know, I think. reagents and reactions, how we are writing, easily you come to know. Nitrogen electronegativity is more. NH bond, like this cleavage possibility is there. NH, very difficult, but possibility is there. So that here what happens, pi electron polarizes. Now it will become plus, it will become minus. Minus accept the proton and this plus accept NH2. So therefore, RCNH2 double bond NH, alkanimide. It is called imide. C double bond NH will be imide, alkanimide. So these are possible chemical reactions of cyano compounds. What are there? One will be hydration. Hydration with water in presence of acid or base. Final products will be alkanoic acid with the liberation of ammonia. Reduction. Reduction that is sodium in ethyl alcohol will give primary amine or CH2NH2. Suppose in place of sodium in ethyl alcohol, hydrogen in presence of catalyst and a lithium aluminum hydride as a reducing agent, if we use the reaction called Mendius reduction. Right. Next, Stefan reduction. Stefan reduction, RCN undergo reduction with HCl in presence of stannous chloride. That stannous chloride convert into stannic chloride, SnCl2 plus 2HCl convert into SnCl4 plus 2H. The two hydrogens will go and add. One of the triple bond may one of the bond, pi bond is going to break down to give RCH double bond NH. That upon hydrolysis with water to give alkanol, aldehyde. Aldehyde with the liberation of ammonia. Clear na? Next with H2S like H2O. Thioalkanamide, RC double bond S NH2. Addition. Right? C triple bond N, one of the pi electron polarize, on carbon SH minus and on nitrogen H. So RC SH minus double bond NH. Again due to more electronegativity of nitrogen, from carbon one more pi electron polarize. Clear na? Then internally SH, that H gives a sigma pair of electron to S, convert into S minus H plus. That H plus internally transferred to NH minus. So that RC double bond S, single bond NH2, thioalkanamide. Next with the Grignard reagent. With the Grignard reagent, addition, adduct will form, that upon hydrolysis with water to give ketones, aldehydes no. Stefan's reduction, preparation of ketones not possible, only aldehyde, important. On that also questions came. And next, ammonia just added to give the respective alkanimide. RC double bond NH and NH2. See, other than this, like that, if any reagent they provided, reactant nature first you have to think. Reactant nature, C triple bond N is there. Pi electron polarizing possibility is 1. If from this electron releasing groups are there. H is electron, R is electron releasing group. In place of that, if H only there, in that case here say, immediately my hand is writing CN, not triple bond N. Wherever triple bond N is given, compulsory the pi electron going to polarize. Just Cn, like Cl, pseudo halide. In that case it is going to break down, hydrocyanic acid. Therefore H plus will come outside. In the similar way, R, like this cleavage, R plus not possible. R is what it is doing? It is transferring that electron density, so that pi electron polarizing. Now from this you have to standardize. See, every reaction the same way, na? Almost same way. Homolysis also done if reduction is there. Homolysis, polarization no. Like this cleavage, homolysis. During homolysis, both the atoms, both the cleaved atoms accept the hydrogen from reagent. Just adduct, here hydrogen, here hydrogen. Later here again polarization. Here I didn't show the polarization. Because polarization means here what should be there? Electrophile required or nucleophile required. But this reducing agent is releasing only H free radical. H free radical nothing but between carbon and nitrogen homolysis taking place. Sir, carbon nitrogen electronegativity difference is more na. Therefore pi electron should polarize towards the nitrogen side. At that time carbon acquires the positive sign, nitrogen acquires the negative sign. In most of the equations you are showing in that way. But whereas here not like that. Not like that, nothing but here reagent है ना, reagent only H radicals को generate कर रहा है, electrophile nucleophile को generate नहीं कर रहा है. इधर आए तो here nucleophile R minus Mgx plus electrophile. Here NH2 रहे तो भी NH2H electrophile, NH2 minus nucleophile. reagent के ऊपर भी डिपेंड रहता. reactant हम always ऐसी रहता बोल के रहे तो reagent in different way. At that time no relation between you and me. सपोज दोनों बीच में सम फ्रेंडशिप हो ना बोले तो उनका ओरिजिनलिटी को थोड़ा बेंड कर लेना. हम ऐसी रहता बोले तो तुम्हारा फ्रेंडशिप मेरे को नको. करेक्ट. सो लाइक दैट यू हैव टू थिंक रिएजेंट नेचर के ऊपर रिएक्टेंट रेस्पॉन्स. सेम रिएक्टेंट रहे तो भी हियर आवर बिहेवियर इज देयर. सी आवर बिहेवियर विथ ऑल सेम रहता क्या? फ्रेंड से वन काइंड रहता, पेरेंट से अदर काइंड रहता, टीचर से अदर काइंड रहता, डिफरेंट काइंड फ्रॉम पर्सन टू पर्सन. Same person behavior with the different peoples, same reactant with the different reagents according to reagent nature. In order to make a friendship, here adjustments are required. Thus here C triple bond N बीच में one of the pi bond is going to become homolysis, free radicals, because here free radical is available. Here ion polarization because ions are available. That thing you have to estimate. Here na? A reagent alkyl cyanide is there, then reagents are different. reagent में check करो homolysis होने का possibility ज़्यादा है, नहीं तो heterogeneous होने का, heterolysis होने का. At that time heterolysis रहे तो इधर polarize कर लो, homolysis रहे तो equally cleave करो. equally cleave करे तो from the reagent both the pieces को both the atoms के ऊपर join होने का ability रहता. polarize रहे तो वैसा नहीं रहता. only H plus goes to nitrogen. NH2 minus goes to carbon. This NH2 minus could not go to nitrogen because negative negative. Clear na? So that common thinking you have to do. On practice definitely you will get. These are the chemical properties of alkyl cyanides. Then alkyl isocyanides chemical properties let us see. थोड़ा different रहता. एक जनरल थिंग हम बोलते तुम्हारा को alkyl isocyanide. Now it is clear. RNC bond nature clear. इनका मतलब क्या है? RN double bond tervalency of nitrogen satisfied, carbon divalency satisfied. In excitation state of carbon 2s1 2px1 py1 pz1 excitation में 2s1 2px1 made the bond with nitrogen. Clear. On this carbon atom 2 unpaired electrons are there, py and pz are there. On nitrogen one lone pair is there, s2. Between that lone pair and here 2 unpaired electrons, the bond is formed, that is the dative bond. We are showing as a dative bond. Whenever in case of alkyl isocyanide this dative bond withdrawn on carbon 2 unpaired electrons appears. Whenever this is breaking down on nitrogen a lone pair, on carbon 2 unpaired, suppose here क्या तो एक reagent add करें हम, AB reagent I am not giving anyone, AB reagent I am adding. Now in this way if the pi electron withdrawn, this lone pair of electrons withdrawn towards the nitrogen side, on carbon 2 unpaired electrons are there. Those 2 unpaired electrons according to reagent will mold. Nothing but both of them can be accepted by these 2 unpaired electrons. Here forcibly AB, nature whatever it may be, should undergo homolysis. If it undergo homolysis, both of them here with this A, with this B. Reagent when we added, nitrogen participation कुछ भी नहीं रहता, just that dative bond contributed pair of electron taken back, that's it. मेरा को कुछ भी मालूम नहीं है reagent से, मेरा electron pair हम ले लेते, तुम क्या करते reagent से क्या भी कर लो. Now like this reagent 2 pieces will go and added on one carbon. After addition, depending on this further reaction, here reactivity depending on these two bonds, again here pi bond इनके ऊपर भी depend रहता. Suppose if it is cleaving like this, homolysis, from the reagent, one of it is going to accept, other will be this, two free radicals accepted. Suppose in this way if polarized, like this if polarized, it accept the positive. In this way polarized is difficult, but here lone pair है देखो, lone pair रहता, lone pair रहे तो ये pi electron towards nitrogen side लेना difficult होता. Clear? In this way polarization, it accept the positive part, it accept the negative part. Okay, na? So this concept you must know from alkyl isocyanates. Now let us see hydrolysis. Hydrolysis, RN double bond C. Hydrolysis is HOH. HOH, whatever the type of cleavage it may be, coming two pieces will be accepted by carbon only. Correct? Coming two pieces accepted by carbon. So that RN as it is, here double bond C, one is H, other is OH. One is H, other is OH. Now, during which again internally, here what will be takes place? Oxygen withdraw this sigma pair of electron. So that the pi electron are polarized in this way. Whenever pi electron polarized towards nitrogen side, this H goes to N. This H goes to N. So that it gives RNH single bond C double bond OH, C double bond OH. What is this? N-alkyl formamide. Correct? HCOOH रहे तो formic acid. HCONH2 रहे तो formamide. On nitrogen if alkyl is there, N-alkyl formamide, it is a secondary amide. Secondary amide. Suppose NN-dialkyl formamide, NN-trialkyl methanamidonium salt. It is a methanamide. समझ में आ रहा है? N-alkyl methanamide or N-alkyl formamide. This N-alkyl formamide on hydrolysis, water is there na, plus and minus. At that time, here nitrogen more electronegative in this way cleavage. During that cleavage, it will become minus, it will become plus. That minus accept the proton, so that RNH2 is a primary amine. Along with that, HC double bond OH. So HC double bond OH is a formic acid. Clear na? Primary amine. Along with that, formic acid we are going to get whenever isocyanide undergo hydrolysis with water. Clear na? Isocyanide, this whatever the pair of electron contributed by nitrogen withdrawn on carbon 2 valencies at a time coming forward. Therefore, from the reagent, two different valence containing radicals will go and add on one carbon only, on one carbon like this. Again here alternate, here oxygen sigma pair withdrawing provision is there due to more electronegativity of oxygen. With the influence of this, here pi electron polarizes towards nitrogen side. So that internally this proton transferred to nitrogen to give RNH C double bond OH is a N-alkyl formamide. That N-alkyl formamide upon hydrolysis with water, CN sigma bond, nitrogen electronegativity is more, so that the sigma pair of electron only will breaking down towards nitrogen side. It accepts the proton from water, it accepts the OH minus from water to give formic acid and alkanamide. Clear? Example, whatever they may give, you can do. Here methyl is ethyl isocyanide is given. Then here methyl will be there. Here methyl, N-methyl formamide. N-alkyl कितना रहे तो भी formamide only. Alkane isonitrile में this intermediate, whatever amide is going to get, you never get other than formamide. In formamide on nitrogen, other substituents may be there. There may be bigger substituents may be there. But formamide basic root क्या रहता देखो, formamide could not convert as ethanamide or acetamide or propanamide or butanamide. It is only formamide because it is alkane isonitrile or alkyl isocyanide. Alkane isonitrile or alkyl isocyanide. So, this compound is going to form it further hydrolysis with water to give the respective formic acid along with that primary amine. Clear? So, that is hydrolysis. And next reduction. Reduction if you do, or again N double bond C like this, hydrogen is coming from reducing agent, hydrogen in presence of catalyst or lithium aluminum hydride. Also you can use, or sodium in ethyl alcohol. Here catalyst, hydrogen catalyst, lithium aluminum hydride or sodium in ethanol. Like this reagents you can use. Here hydrogen coming forward, two hydrogens initially or N double bond CH2. Clear? इधर बॉन्ड ब्रेक हुआ तो दोनों पार्टिसिपेशन नहीं करते, only this carbon will take because just it is withdrawing a lone pair of electron towards it as it is. Therefore, this compound is going to form. This compound upon further undergo reduction. तब क्या करते? A one bond is going to homolysis. During homolysis from two hydrogens, one of the hydrogen goes to nitrogen, other hydrogen goes to carbon. So that RNHCH3 is what? Secondary amine. Alkyl isocyanates upon reduction will give secondary amines, whereas alkane nitriles upon reduction will give primary amines with the same number of carbon atoms. Okay na? Reactant में कितना number of carbons रहता, product में भी same number of carbons रहता. So therefore RNHCH3 is a secondary amine. That is the reduction of alkyl isocyanide, hydrolysis of alkyl isocyanide. During hydrolysis we will get a primary amine along with the formic acid, whereas during reduction we will get a secondary amine. Okay na? Suppose some addition reaction if you take, addition reaction, oxygen with mercuric oxide, oxygen is coming. So, RN triple bond C almost, this with oxygen in mercuric oxide. Now you can expect very easy. Nitrogen withdraws a lone pair of electron. Now here divalency appear on carbon atom. Here oxygen is also divalent. Therefore, RN double bond C double bond wo na? RN, here lone pair taken by nitrogen, here double bond is there, that on carbon two valencies coming forward, oxygen is the divalent. Therefore, two valencies and divalent, double bond is going to form na? What is this? Alkyl isocyanate. Alkyl isocyanate is going to form. Clear? Next with sulfur only, for which other supporting reagent no need. With sulfur, other supporting reagent no need. That is RN with S. Then RN lone pair as it is, double bond C, double bond S. Only this pair of electron if withdrawn at a time, the carbon divalency coming forward, that you have to remember. First, nitrogen could not involve, keeping double bond as it is, and divalency of carbon will be satisfied from the reagent. If the reagent is monovalent, two monovalent units will be taken by carbon. If the reagent is divalent, only one divalent unit will be, or reagent will be taken by carbon. If the reagent is trivalent, at that time formula is going to change. It accepts, this total accept 3, this total accept 2, because carbon divalent, here reagent is trivalent, according to criss-cross principle. If in that way it comes, right? So it is what? Alkyl thioisocyanate, alkyl thioisocyanate. Suppose monovalent I will give you with chlorine, is it having reaction? Or N double bond C with chlorine. Chlorine is Cl2. Two monovalents are there, na? Like H2. Two monovalent, it can withdraw. Easily you can get. You can withdraw this one. So that here R N double bond C Cl2. Correct? If it is this C double bond, if it is O, what is that? Phosgene, carbonyl chloride. This also in terms of carbonyl chloride we have to define. This is alkanimide. N double bond O is imide. Alkanimide. Alkanimido carbonyl chloride. Alkanimido carbonyl chloride. Alkanimido carbonyl chloride. Okay, na? Now reactions clear, na? Whereas isocyanates wherever is there between N and C, you expect this dative bond type. Depending on reagent, a pair of electron withdrawn by nitrogen. When it is withdrawn by nitrogen, here on carbon only two valence is coming forward. Therefore, from the reagent, those two valence according to reagent nature will go on to satisfy. If they satisfied, you will get like this. Further, if you want to involve this in a reaction, if you want to involve in a reaction, nothing but here nitrogen more electronegative among all. Therefore, depending on reagent, pi electron polarized towards nitrogen side. Whenever pi electron is polarizing, it will become minus sign, therefore on which proton, here some other negative reagent will go and add. And further, if that is stable, stop there only. Otherwise, internal conversion again is going to take place, may break down this, convert into NH2. Suppose this is there. This here I am keeping in water, H plus and OH minus. In this way, cleave this N will take the hydrogen. N will take the hydrogen from water. Here single bond C, unko double bond S, it accepts the OH. Correct? This double bond S is as it is, a double bond S ऐसे रह के accept कर दिए. Accept करने के बाद again this if you want to keep in water, what happens? Plus minus. Here electronegativity difference here also there, or else internally in this way it is going to take place. In other way also I will show. One possibility this side, H plus goes to nitrogen, convert into RNH2 plus. This accept the OH minus, COH minus double bond S. If you convert it is H2CO3 type of, this is S. If S is O, is H2CO3 na? Carbonic acid. So it is the thiocarbonic acid. Thiocarbonic acid. That thiocarbonic acid, if on this carbon 2 hydroxyl group, if we feel on heating also, lose water molecule to give C double bond S and double bond O na? Thiocarbon dioxide. If it is oxygen, carbon dioxide, thiocarbon dioxide. Here only other path I am telling. Due to more electronegativity of oxygen, in this way cleavage. Due to that cleavage, here the difference is more. Here two possibilities are there to the carbon. Here pi electrons are there. Here sigma electrons are there. But pi electrons से link में रहे, so sulfur is less electronegative. Oxygen भी नहीं है ये. इनका electronegativity is less. It is a more electronegative. Therefore, this bond is going to cleave. Now a minus, a plus. Therefore, this internally proton transfer to here. When this proton transfer to here, RNH2, along with that C double bond O and double bond S, C double bond O and double bond S, without consumption of water. With the consumption of water, obtained product on heating lose the water molecule. Clear? Just if you go on practice with the reagents, changing the reagents, if you go on practice, then this hand only is going to do. Clear? So these are chemical properties of alkyl isocyanides. Usages if you go, mainly CH2 double bond CHCN is there. What is this? Vinyl cyanide. Vinyl cyanide can also known as acrylonitrile. Vinyl cyanide or acrylonitrile. Here double bond. Actually, if it is H, ethene. Ethene under condition. N moles of ethene under condition. What it will give? CH2 single bond CH2 taken N. What is that? Polythene. ये डबल बॉन्ड ब्रेक होता उतना ही, इधर ये एक्सटेंशन में जाता और दैट इज एक्सटेंशन. Here CN is there, one of the CN will be substituted like that. It is a polyacrylonitrile pan. Polyacrylonitrile or polyvinyl cyanide also we can say. Polyvinyl cyanide. ये cyanide प्लेस में Cl है समझो. Polyvinyl chloride PVC. Generally as a monomers these cyanides are going to use. This is unsaturated cyanides are going to use to get a macromolecules in polymer industry. Clear? So this is organic chemistry containing nitrogen atom as a heteroatom. This is there in your NCERT syllabus. ये छोड़ के whatever others are there, nitro compounds are not there. So therefore nitro compounds का discussion का need नहीं है. टेक्स्ट बुक बैक साइड रहे तो क्वेश्चंस भी एक बार देखेंगे. यू मस्ट बी थरो विथ व्हाट एवर देयर इन टेक्स्ट बुक. टेक्स्ट बुक एग्जाम्पल्स रहता, प्रॉब्लम्स बैक साइड रहता, टोटल टेक्स्ट बुक वर्ड्स रहता. एनटीए क्वेश्चन पेपर्स देखे तो एनसीईआरटी टेक्स्ट बुक छोड़ के नीट और जेईई मेंस छोड़ के नहीं जा रहे, एडवांस में जा रहे. नीट और जेईई मेंस में छोड़ के नहीं जा रहे. एंड एनसीईआरटी टेक्स्ट बुक वॉट एवर इज देयर उतना ही परफेक्ट पढ़ने का एवरी स्टूडेंट को पॉसिबिलिटी है. थोड़ा एप्लीकेशन में गए तो ही उनको समझ में लेके और लिंक्स सेट करने के किधर तो थोड़ा एक जगह पे जाता, मगर स्ट्रिक्टली स्टिक ऑन टू एनसीईआरटी इज नॉट डिफिकल्ट फॉर एवरी इंडिविजुअल स्टूडेंट. सो देयरफॉर टेक्स्ट बुक में क्या क्या रहता देखो, वो परफेक्ट हो जाना पहले. That is the reason why whatever other reactions I taken, even though I postponed, whenever time requires at that time किधर तो तुम्हारे को some reference book refer करते देखो, उसमें questions पूछते other than NCERT, different models में लेके जाते देखो. Actually that is a non-directional for NEET as well as JEE mains. Advance में जा सकते. एक तुम mind में रख लो, what is there NCERT, try to get a perfection. If you get that, definitely you are going to score very nicely. वो हमारे से हो सकता, unnecessary fear no need. ओके ना. मटेरियल करते देखो, मैक्सिमम क्वेश्चंस रहता, पूरा करने को हम जाते, पूरा करते देखो क्या तो एक 5 to 10% अनइवन रहता. अनइवन नया है तो अननेसेसरी हम क्या तो हम बैक में है बोल के नहीं सोचना. ट्राई टू स्टिक ऑन स्ट्रिक्टली टू एनसीईआरटी बुक. अल्काइल हैलाइड्स का बैक साइड क्वेश्चन हम पीयू का रहता बोल के नहीं करे. नाउ इनका करके आउट टाइम रिक्वायर टाइम हमारा कोई रहे तो अल्काइल हैलाइड का भी करेंगे. ओके ना. राइट, रिमेनिंग नेक्स्ट क्लास.